Hello and welcome to this session on Introduction to Image Data Compression. In this video, as first objective, will to see the various fundamental terms, the definition and evaluation criteria. The second objective is to explore the different compression techniques and perform at least one lossless and one lossy compression method on a given image. The content of video is prepared using following books. So, to begin with, let us define the term data compression. Data compression is a process of reducing the original amount of data f of xy to compressed data gxy. Decompression is reverse process of compression. Input to decompression is g of xy and the output is f cap xy. The storage space can accommodate more amount of reduced data. Similarly, more amount of data can be transmitted over given bandwidth and time. Data might contain elements that provide no relevant information. These elements are called data redundancy. So, different amount of data can be used to represent the same information with different redundancy. Compression of data is possible by reducing redundancy present in it. Redundancy is measured using compression ratio. Let N1 denote number of units in original data set f of xy and N2 denotes number of units in compressed data set gxy. We should represent the same information. Redundancy is 1 minus 1 upon compression ratio. Compression ratio is ratio of N1 by N2. If N1 is equal to N2, there is no redundancy. If N1 is very large as compared to N2, the redundancy is higher. If N2 is very large as compared to N1, there is expansion. There are three types of redundancy. So, different techniques can be used to exploit different types of redundancies. For example, half-moon coding can be used to exploit coding redundancy, and interpixel redundancy is used to exploit spatial redundancy. Geometric redundancy or even interframe redundancy. Whereas run length encoding can be used to exploit interpixel redundancy. Cyclic redundancy is used to inability of our naked eyes to perceive it and distinguish the actual difference between original image and compressed image. Cyclic redundancy can be exploited using improved grayscale quantization. In this video, we will see how interpixel redundancy and cyclic redundancy are exploited using run length encoding and improved grayscale quantization respectively. Reflection spot. Pause this video, think for a while and write your answers for these questions. Once you have finished your answers, play this video. Let us understand few more important terms related to information theory. What is data? If I write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, don't say anything. Then you don't understand what is it. So, if I say this is my mobile number, then I am attaching information to it so that outside world can understand what it is. So, data is not as information. Though we can measure both, data is measured by its size, that is the number of characters or digits, bits, bytes, and so on. Information can be measured using logarithm over probability. If we conduct an event of tossing a coin once, there are two possible outcomes, head or tail. So, the probability is 0.5. That means, in this event, at a time, we can get only 50% of information, that is, one head or tail information. But the information is presented using one bit, that means there are two distinct information present in the event. The outcome is uncertain, but the amount of information one can get or process is certain. So, information is also called as self-information. Event with high probability gives little information and vice versa. Now, what is knowledge? If I tell you my mobile number is 123, no one would accept it, knowing the fact that mobile number is actually 10 digits long. And this comes from knowledge. Now, the question is, can we measure knowledge? And the answer is no. Knowledge cannot be measured. And thank God, it is so. Wisdom is an ability of utilizing or applying this knowledge and experience with common sense and insight in a day-to-day life. It also cannot be measured. Entropy. What is entropy? Entropy is a measure of uncertainty. Recall the definition of self-information. Self-information is used to calculate an entropy. It is multiplied with probability. To understand it better, recall the event of tossing a coin where the probability of getting head or tail is 50% and the information is 1 bit long. Efficiency of entropy, an average number of bits per pixel. Detailed discussion on entropy and efficiency is out of scope of this video. There are two different types of compression techniques: lossy and lossless. Recall f of xy, g of xy and f cap xy. In lossy compression techniques, f of xy is not equal to f of xy cap. Lossy compression techniques give more compression ratio at the cost of information loss. This information loss is termed as error. Mean square error and signal to noise ratio are objective criteria used to measure the quality of lossy compression techniques. Another way to measure the quality of lossy compression technique is subjective error criteria. There are different levels beforehand. In this case, there are 7 different available levels that can be assigned the quality of lossy compression techniques. It varies from person to person and application to application. As we know, there are 2 main categories of compression techniques. The first category is lossless compression technique. Now, let us list down few well-known lossless compression techniques. Among these techniques, we will discuss one solved example on run length encoding. The second category of compression technique is lossy compression. Lossy techniques achieve more compression at the cost of information loss. Few well-known lossy compression techniques are listed here. Among these techniques, we will discuss one solved example on IGS quantization. So, let us move to a next reflection spot. Think and write now about these 2 questions. Pause a moment and try to answer these questions. Once you have finished your answer, play this video. Let us understand how RLE works and how the performance is measured. We already explained the RLE's lossless compression technique where f of xy is equal to f cap xy. In this example, we will try to prove the same. We know that the RLE fails on color images. So, let us take 4x4 binary image input f of xy shown in the top left part of the table to perform RLE. So here N1 is 16 bits shown in the bottom left of the table. There are 3 runs of 1, 0, 1 with length 3, 6, 7 respectively as shown in the red color. Let us assume that each length is represented by 3 bits. The RLE code is gxy equal to 130617. As each pixel is 1 bit and there are 3 runs, the value of N2 is equal to 1 plus 3 into 3 is equal to 12 bits required to represent the compression data. Performance of RLE is measured using compression ratio and data redundancy as shown in the bottom right part of the table. From code 130617 we can denote and decode as 3 ones, 6 zeros and 7 ones. Stored it as f cap xy. So f of xy is not equal to f cap xy. Now let us look at IGS quantization technique. To take this as an example, where f of xy is input to IDS code. Let us see the procedure of IGS quantization. This is how it works. Now we know the quantization leads to error, and hence f cap x is not equal to fx, as shown in the second last column in this table. If 50% of the most significant bit of current pixel are all 1, then we don't change it. Otherwise, we add 50% of LSB bits to current pixel to 50% of MSB to the next pixel. The summation of all 50% of most significant bits from each pixel becomes IGS code. The above procedure step by step is shown in this table. After assumption process, 50% MSB bits are shown in red color. As input 6 bits, there are 9 pixels in the image. N1 6 into 9 equal to 54 bits. Also, as input in 6 bits image, IGS performs 50% quantization. N2 is 6 into 9 upon 2 is 27 bits. Compression factor is equal to N1 upon N2, which is 2. MSB is 46 and PSNR is 39%. Now to summarize, we saw how to apply lossless and lossy compression techniques, how to find compression ratio, redundancy, how to calculate self-information and entropy, how to calculate error, signal to noise ratio, and how to measure the quality or performance of compression techniques. Thank you.